Hi, everyone, and welcome. My name is Mike Nichols, and I'm the manager of content and social media at AM. And on behalf of the entire team, I want to thank all of you for joining us today. So with that said, really excited to have James Logan with us today as our presenter. James leads the AEM water sector. James has actually been involved in the assessment, design, development, and implementation of more than 200 flood early warning and environmental monitoring systems across the US and abroad. He's also led numerous consulting studies related to rainfall and hydrologic analysis, flooding, stormwater, dam safety, hydrology, and water resource management. James holds degrees in both computer science and geophysical engineering, and he's a member and contributor to the U.S. National Hydrologic Warning Council's technical working group for the Alert 2 protocol standard. So today, James will be talking to us about a framework that can guide your decision making when developing or expanding a flood warning system. Without any further ado, James, I'll turn it over to you.
Okay, thank you, Mike. So today I'll first talk about an overall framework for managing hazards with early warning systems, and then I'll specifically apply that framework to a flood early warning system and then walk you through the 5 steps or components of the solution. And then I'm going to give you a couple of real-world examples of systems that have been either designed and implemented or just completed their design phase. So first, I'd like to discuss an overall framework for hazard early warning systems. So this is a framework that can support landslides, wildfires, drought, flooding. It's designed for any type of hazard. This framework that I'm talking about is consistent with the framework that the WMO uses, and there's a framework that United Nations Disaster Risk Reduction Agency uses for how they look at risk management and systems for managing risk. And the World Health Organization also uses a framework, and this framework is consistent with the way they do things. And so we've chosen it because it's a common framework that is essentially worldwide certified, and it gives a standard approach to dealing with these type of risks. And the 5 steps, the first is risk knowledge. So it's basically understanding the risk of the hazard. And so that's the basic understanding of what the system is going to be trying to protect and what are the potential risks that could apply to people or businesses or infrastructure, what would be impacted. And then the second step is the monitoring solution. So what type of monitoring do you want to put in place to understand in real time and on an ongoing basis where the risk is actually happening and what's going on. And then the third step is dissemination and communication with either agencies that are responsible for responding or to the public. It depends on the application that you're doing, but it can be communication to any of those. And then the fourth step is the response case capability. So that's how does the public or the agencies respond to the situations. The fifth step is evaluation and improvements that are done once you have a situation where an event occurs. You want to have a process where you take what you've learned from each time an incident happens and improve your processes so that the system works better the next time. So this type of hazard early warning system approach, it can apply to any type of hazard. So it can apply to meteorological hazards, it can apply to wildfire, and it's a common framework that can be used. So now let's take that example of the framework and let's apply it to flood warning. So in doing that, let's look at these same 5 steps, but apply them specifically to the flood early warning problem. So the first step in the assessing the risk is, in this case, we want to assess the flood risk. So this is looking at things like where is it flooded before, what do the existing floodplain maps show as far as a 10-year, 20-year, or 50-year, or 100-year flood? What are the potential areas that get impacted by those things? And looking at where your populations are, where your businesses are, where your transportation infrastructure and things that could affect commerce, where those things are that could be at risk due to flooding. And then once you've done that assessment, then you develop a monitoring system and a forecasting system that looks at measuring and forecasting the potential for flooding in those areas, and you design it so that you're primarily trying to understand when those risks are going to hit the areas that would be most impacted by the flooding. So the monitoring system is really custom built for the situation where you have people and infrastructure that you're trying to protect. The third step then is that you want to communicate whenever there is an event or a pending event. You want to be able to communicate it to the appropriate agencies and potentially to the public. And there are situations, we work with some agencies where all the communications go only to the emergency management agencies, and then they manage it from there. And we have other situations, for example, we have parks that have been built along rivers, and in those situations, there has to be a full self-contained system where you measure, predict the flooding, and then you start and send out sirens so you can get people to evacuate from near the river, because we've had a lot of situations where people that camp along a river or are close to the river rises so fast they can't get out of the way, and they end up getting carried away by the floodwaters, and it's a bad situation. So in those situations, we put in real-time systems with sirens and direct notification to the public to get them out of the way when those events are occurring. Step 4 then is the response to flood hazards, and that is essentially what most people are familiar with, which is an emergency action planning. It's the actual emergency action plan that are typically pre-built scenarios that are set up so that the public knows where to go when there's an event, and they're educated on that. And also all the emergency management personnel also know that. So everybody has the same plan whenever an event's happening to get people out of the way of the flooding. And then the last step is, after every event that happens, you want to evaluate the system. You want to look at everything that's worked and everything that didn't work, and anything that didn't work, you want to come up with alternative ideas to make that part of the system work next time. So it's a continuous improvement process that you apply to these systems so that they get better and better at dealing with events over time. You learn from things that both worked and things that didn't work. So this is a cycle, these 5 steps, they're related to each other, because essentially when you end up building a system, you build it in the order of the 5 steps. You develop the risk knowledge, you use that information to design and develop the monitoring and forecasting capabilities to protect those resources that are identified in the risk knowledge section. Then you develop how you're going to communicate to the agencies or the public. And then the response capability is the last step, which is you develop the emergency action plans on how to get people out of the way, because by the time you develop those, you have knowledge of where the flooding is going to occur, where the populations are, and you build emergency plans to get them out of the way into safe locations. So this numbering system is consistent also with the order that you go through when you're developing the systems. So let's now look at it specifically for a flood early warning system. Step 1, we mentioned assessing the flood risk is what you want to look at. So let's look at what that looks like. So this is the risk knowledge step of understanding the risks. And the types of ways that this is done is that you gather lots of information. You gather information on what the floodplains look like for different return periods, populations, population densities, where buildings, hospitals, and schools are, because you have people at risk. You might also have some senior living homes that are nearby. Those are all potential people that could be at risk during a flood, and you want to make sure you understand where they are so that you can build plans around getting those people to safe locations. Roads, it's important to understand roads because you need transportation for long-term support of an area after a flood. You need to know what roads are going to be blocked by the flooding and what roads are going to be safe roads that people can travel on to get out of the way. You also want to have long-term knowledge of which roads will be around and available after the flood so that you can support the people and get them resources and food and other things they need after a flood, how you're going to get that stuff in and out without going on places that are potentially damaged by the flooding. If there are any existing evacuation routes, so if there ever has been some previous work done to develop emergency action plans and evacuation routes, you want to have that information. You also want to have good knowledge of the drainage basins. So the large drainage basins, especially the larger catchments, if the rain is hard, the size of the catchment is proportional to how much water it ends up concentrating in areas that flood. So understanding the drainage basins and how large they are and how fast they concentrate the water into the channels, the rivers, and other locations is important. So that's the type of information that you gather. There are other things you want to think about when you're gathering that information. You want to understand how much time you need to evacuate people. So let's just say that you have situations where you have a hospital that's in a floodplain. When it takes a long time to evacuate people out of a hospital because there's a lot of care and planning that needs to be done to get people out safely because they're already under some type of medical care. So those types of places, they need to have a lot of advance warning. There are other situations where you really don't need a lot of advance warning, where you really just want to notify people to stay out of an area that has potential for flooding. You just want to tell people to avoid those areas. So depending on the situations, there's different times that are needed to help the people and get them out of the way. And that's something that you want to understand. What's the amount of time you need? You also want to understand the relationship between all the catchments. I mentioned that the size of the catchment has a lot to do with the amount of water it can concentrate in specific locations. The steepness of the terrain impacts how fast the water concentrates in specific locations. So that information is also useful at this first step of the analysis. And you also want to understand what type of communications channels you have to communicate to the public, because you may want to use public communications like cellular, TV and radio station broadcasts and sirens, but you also may want to have signage and gates that close access to places that are high risks. For example, that maybe there's some roads that go right near the rivers, and that's where the flooding is going to happen. You want to keep cars and people from driving into those areas, so you want signage and things like that to keep people from going into those areas. So now let's look at the second step of a flood warning system. This is the monitoring and forecasting. So once you understand the risks and where the people are at risk and where infrastructure is at risk, now you want to develop a monitoring solution for those risks. These systems can be made up of a lot of different components. So there are rain gauge networks, stream gauge networks. So rain gauge networks will let you know how much rain is falling on the ground so that you can understand where it's raining heavier and where it's raining less, and also understanding the relationship of the rainfall to those drainage basins I discussed. You also want to have stream measurements so you can measure the flows through different locations along rivers and important channels, so you can use that information to understand the risk. It's also good to know, for example, if there's a city or a town located along a river, if you have monitoring upstream from the river, that gives you good knowledge of the water levels in advance of the water reaching the town that you care about. And so understanding the relationship between those stream gauge measurement locations and populations and towns below gives you knowledge of how much time you have to prepare the system for those types of risks. Radars are a really good way of getting rainfall information, because rain gauges only measure rainfall at individual points wherever the rain gauge is, and it's usually a small opening at the top of the rain gauge, where radars give you knowledge of the rainfall spatially over a large, broad areas, and so you have a better understanding of the variation of rainfall. So that's very helpful. Gauge adjusted radar rainfall is essentially a processing product that's created from the radars and the rain gauges to give you a high resolution rainfall grid over your full area of interest. And so that's a sort of a higher quality, more accurate product of understanding the rainfall. And it's very useful, especially when you're doing modeling applications to do forecasting, that understanding the amount of rainfall spatially over your whole area provides much better results and a much more accurate prediction of runoff and modeling. Atmospheric models, they're a big part of it. Almost everybody in the world depends on weather forecasts that come from these atmospheric models to understand what's coming and what is, and even what's happening over them right now. So they're very useful. Hydrologic models are basically a computer model that takes and models how fast the rainfall hits the ground and how long it takes to run on the ground to concentrate into rivers, and it gives you a good computer model understanding of the flows that would be generated from the rainfall that's occurring. In addition to the real-time measurement, which I was talking about in that last situation, you also have situations where you want to do forecasting. And forecasting, it adds a lot of information to the flood warning problem, because forecasting gives you an idea of what's going to happen in the future. And so if you don't have very much time to get people evacuated, or if when you're looking at the risk side of this, you realize that you need more time in order to notify people and get them out of the way of the flooding, forecasting allows you to extend the amount of time and have more time to get people evacuated, because you can predict what's going to happen in the future, and then you use that extra time to deal with notifying the public and getting people out of the way. So this forecasting has a big advantage, and it improves your amount of warning and your amount of time before the event actually is a situation where people's lives are in danger. It gives you more time to prepare for that. So it's a very important tool when you're designing flood warning systems, and sometimes you have to take that into account. The third step is dissemination and communication. So once you understand that a flood is going to happen and you have information on it, how do you communicate that to the public? And as I mentioned, some of them communicate directly with the public, but other systems only communicate to emergency management agencies, and then those agencies take responsibility for the communication at that point. So this is a delineation point depending on what existing agencies are there and whether they already have these responsibilities or not. When you look at the communications, some of the things that are important is who is basically your customer for the flood warning system. Is the customer the public? If the customer is the public, then they're the ones you end up notifying and providing the information. But as I mentioned, there are some situations and some agencies where the emergency management people have responsibility for all communication to the public, and they become the agency that you give all the flood warning information to, so that they can do their job and communicate it the way that they've already planned to do it. So we see this whenever we're implementing flood warning systems, is we really have to understand what existing agencies there are and what are their responsibilities, and are they the agency that is prepared to take this information? They have all the plans to act on it, or are those agencies needing support in developing their plans on how to act on the information that we provide them? So step 4 is the response capability. So this is the part of the system that after you know that it's flooding and you've been able to at least notify people that flooding is coming, what do the people do once that is happening? So you develop plans on how people can evacuate. So this is an example for evacuations from a mountain town. Where do the people live in these areas, and which roads should they use to get out of the areas that they live in? And so these are typically a pre-planned evacuation. So in developing emergency action plans, you come up with what are the main scenarios you want to deal with on an emergency basis. And then for each scenario, you develop a plan on how to deal with that. What does the public do? What do the emergency management agencies do when an event is happening? There are some agencies we work with where they send out all the public works people out in trucks with gates to go block roads to keep people from driving into roads that will be flooded. So they drive to 100 locations and they take their truck out and they put a roadblock up to stop people from driving into that road. And then they go on to the next location and block all the roads to keep people from driving into places where cars would get washed away. And at least in the US, the majority of people that die in flooding die in vehicles. So they drive into water that they think is not that deep, and they go into it, and then the water washes them away in their vehicle and they drown in their vehicles. That's why some of these systems are really built around road information for flooding, because that is the most common way, at least in the US, that people die during floods. In other areas, it's just there's so much water that it doesn't matter whether you're at home in your house or whatever, the water overcomes the people and they can't get to safe places. So these emergency action plans are designed to help predefine where should people go to be safe, how should they get there, and gives them a way to get everybody out of harm's way from whatever the particular risk that we're trying to design it for against. So that's the concept. And these emergency action plans are very important, and every system, it should be part of the overall solution. And as I mentioned before, in some situations when we build flood warning systems, the responsibility of the emergency action plans falls in a different group, but that's okay. We just want to make sure that's taken care of so that the whole solution that we're trying to solve for the agency is being handled. So the final step, and this is an important thing with any system, in general, I would say this is a common thing that should be done to any project that anybody does, which is that you don't just build a static system and hope that it continues to work forever. The best systems out there are the ones where after anything happens, there's a process of evaluating the overall system and figuring out what worked and what didn't work. And then you go and improve the things that didn't work so that the next time those problems don't happen. So that's a very important part of the process that we're presenting here, is that continuous improvement loop to make the system work better and better over time. So what do you evaluate after an event is you want to understand what worked right, because you want to be clear that those things that you did then are the right things to do. What went wrong, so you can look at those things that went wrong and try to find ways to do those things better so that they won't go wrong again. You want to make any improvements that you can to the system for things to run more efficiently or to fix things that went wrong. And the idea is that the next time everything should work better, and the next time you still go through the same process again at the end of it, you evaluate what worked and what didn't work, and you try to fix it even better, so that as time goes by, the people dealing with the floods get better and better at dealing with the problems, and you get situations where less and less people are in danger, and less people get hurt or killed in the floods. And we've actually seen this type of improvement. We've had some floods in an area where I live in, where there was in the 1970s a flood that killed hundreds of people. And in the same basic area, we had another rain event that happened about 10 years ago that had much more widespread rainfall and much heavier rain and impacted a much larger area, and a lot more population was at risk. And because we had developed protocols for dealing with flooding, measurement, warnings, and getting people out of the way, signage to tell people to climb to higher ground if there's a flood event, there's all this overall communication that happened. The event that happened 10 years ago, there were only 3 people killed in that event. The event that happened 10 years ago happened over approximately maybe 20 or 30 times the area of the previous flood. And it had more rainfall and more impact of flooding. But because people were educated on what to do and there was much better knowledge and monitoring and warning, only 3 people died in that situation, which really, it's bad if anybody dies, but the facts show that this type of preparation from flood warning systems and communication and this process that we talk about in this presentation, it does save lives and it makes it better than it was, and it's quite a bit better if these type of processes get followed. Now I'd like to talk about a couple of real-world examples of flood warning systems and how this particular process applies in those situations. So first I'll talk about Donna Ana County. So this is the Las Cruces area of New Mexico. So it's an area that's near the Rio Grande River, and it has a lot of flooding. The area is very dry. When it rains, most of the rain turns into runoff right away. It causes flooding, mostly it's flash flooding, and it's a pretty large area with very little infrastructure to manage flooding. Most of the roads are dirt, and things haven't been developed to do flood control or anything like that in this area. They didn't have a flood warning system at all. And so what we did is we helped them develop a master plan. So it was a 5-year plan. The first thing we did is we worked with them to identify all the risk areas. So we identified all the places that flooding had happened in the past. We identified all the places that the hydrology told us that there were going to be potential flooding in the future. With all that information, we used that to design a monitoring network, and we prioritized everything in the monitoring network. So we essentially designed a pretty complete monitoring network overall, but we built a matrix where we prioritized every monitoring location so that we could identify the potential downstream impact of that monitoring location on providing information. Are there people that it would protect? Is there property that it would protect? Is the location able to be permitted for us to put equipment on that location? Is the location accessible for long-term maintenance so that we can maintain the sites? This whole matrix became a way for us to take what turned out to be like 250 potential sites for doing the monitoring, that it allowed us to prioritize the top 20 or 30 sites that would give the agency the most value to begin with and be the best long-term locations for monitoring. And it helped us build out the plan. As I mentioned, it was a 5-year plan, so we built it out so that they would implement 20% of their gauges in the first year, 20% in the second year, and then essentially get all their gauging network built over a 5-year period. But they got more value out of the early stations because those were the higher priority stations that would give them the most value in the beginning. And so it allowed them to get the most bang for their buck in developing the system. So once that design was done, this particular agency was not taking responsibility for doing the emergency action planning and the public notification. So this system was really those first 2 steps that we talked about in the process. And then that 5th step of doing continuous improvement, that's how they've been operating since then. They've implemented the system and they've been running the network, and they're still going through the improvement process. But our solution for them was to build the flood warning, the monitoring network. We didn't do the steps 3 and 4, which are the public communication and the emergency action planning. But in their case, they benefited from this approach, especially this first step of building a bunch of information out about the risk areas and where do you need to put the monitoring in, because it informed us when we were building the monitoring network to put things in the best locations possible for this agency. So another example, and this is a project that we've just wrapped up the first phase of the design for, is a national flood warning system for Peru. This is a project that followed the same 5-step approach. So in this situation, we did an evaluation of the risk. We defined from that where are all the vulnerable locations, and then the monitoring network was designed to support giving information on those vulnerable locations. In this situation, they have regional emergency operations centers that they use, and they take all the information from the monitoring network and information on what the vulnerabilities are so they can see them all together on maps. And as the flood events occur, they can look at this information and use that to make decisions about activating alarms and initiating evacuations. And so this particular project used all 5 steps that I described in this meeting. So it's been very useful. I just want to recap. This is the framework adopted by world agencies. And I think it's a really good framework to think about when you're building systems that help you manage the risk from hazards, whether they be environmental or otherwise. So the 5 steps that we're talking about are risk knowledge, monitoring and forecasting, dissemination and communications, either to agencies or the public, and then the response capability, which is really the emergency action planning and building pre-planned methods for trying to get people out of the way of the risk. And then the step 5, which is not directly called out in some of those other frameworks, is to have a standard process for doing evaluation improvement so that the system gets better and better over time. And for us, this is the framework that we think that most agencies should adopt that are considering doing a flood warning system.
Thanks, James. That makes sense. Thanks to everyone for attending. We really appreciate it. Have a great day.